Good evening, all. Hope I am clearly audible and just sharing the screen and just confirm me whether the screen is clearly visible or not. Is it visible clearly?
Yes, ma'am.
Yes, ma'am.
Okay. Thank you so much for the confirmation. Okay, so I just going to discuss as per the instruction that some of the leftover part and questions of the paper 1 and 2 of ISS of last year question. As you can see, it's open in front of me and I'm sharing the question. Uh, I'm I'm going to choose some arbitrary question as given to me. I think this question I have discussed in the last class already, so I'm skipping this one. 28 already has been discussed. So let's start with paper 2 first. There are many more questions to be discussed. Okay, I'm going to start with question number 9. Okay, please read out the question. I'm giving you 1 minute. Please read out the question. If you already have the question, please refer to the question. This is paper 2, booklet A, question number 9. It is saying that they are referring to a two-way classified model. The usual notations are there, and they are giving us the which of the following parameters are estimable, like alpha, beta. One is alpha, another one is beta, another one is alpha I minus alpha u, where both I and u runs from 1 to p, but I not equals to u. That means not the same pair, obviously, otherwise it's going to be 0. And another thing is alpha 1 plus alpha 2. Which one is actually estimable? They wanted to know that particular thing. So, how can you determine this thing? So, basically, the easiest method of determining this thing is first let us write the model. This is my model where I runs from 1 to p and j runs from 1 to q. Okay, so if I split it up for any fixed I equals to 1 and j equals to 1, my observation will be y11 equals to mu plus alpha 1 plus beta 1 plus E11. Then gradually fixing I at 1, I am putting j equals to 2. For j equals to 2, my observation will be y12 equals to mu plus alpha 1 plus beta 2 plus E12, and it will go up to j equals to q, since j runs up to q. Okay, so I will get y1q equals to mu plus alpha 1 plus beta q plus E1 q. So similarly, if I can, so what varies over here? I am varying j, fixing I at 1. I can do the same thing fixing I at 2, I at 3, and up to I at p. So in this way, I can going to get the whole data set. So it's impossible to write the whole setup. I'm just showing it for one case. So if I go by the option, so in this way, only alpha is impossible to estimate as it is not present. If I am considering a two-way model over here, my first null hypothesis, if you can remember, for two-way model is alpha 1 equals to alpha 2 is equals to alpha p is equals to alpha. Under the null hypothesis, if and only if my null hypothesis is considered to be true, then only I can take this to be alpha. So there is no alpha over here present in my model. Either it is going to be alpha 1, or it is going to be alpha 2, or it is going to be alpha p. So there is no single, any symbol alpha is present over here, and in a similar manner, no symbol beta is present over here. So directly we can cancel out option A and option B. Next, alpha 1 and alpha 2. If you can see this writing very carefully, we are fixing I and moving j. Not at a time, both are being moved. So whenever we are moving j and fixing I, so we are not getting alpha 1 plus alpha 2, these two terms at the same time. So if we want to estimate this alpha 1 plus alpha 2, it's impossible to estimate this whole thing together, since we are getting these two things separately. We can get a single estimate in general of alpha I for I running from 1 to up to p. We can get separate estimates of alpha I, but we cannot get the estimate of this thing. We cannot get the estimate of alpha 1 and alpha 2 as the sum of alpha 1 plus alpha 2. So this option also gets cancelled. So the only one option left is the two different alpha 1 minus alpha u, where obviously I is not equals to u and both runs from 1 to p. So C will be estimated, is basically estimable. Is it clear? Okay, now moving on to this particular question number 15. They are saying that x1, x2, xn is a IID random variable from the density function 1 by alpha e to the power minus x by alpha, whether x ranges from 0 to infinity and alpha is greater than 0. Obviously, it's an PDF of an exponential distribution, as you can see. And you need to show that what is the uniformly minimum variance unbiased estimator of the parameter alpha. So let us write the distribution first. So my fx is basically 1 by alpha is x by alpha, where 0 less than x less than 0 otherwise. This is my fx, where alpha is greater than 0. So this is what is given, and I need to find an uniformly uh, minimum variance unbiased estimator, that is UMVUE. Okay, so first of all, I need to seek for an unbiased estimator, and then I need to show that whether it has the minimum variance or not. Okay, so obviously, as we know that intuitively the result is almost known to us, that x bar is the result, but we need to recheck it. Let us start. Let's go by the option. First, we are going to start with the option x bar. Let's see that the whether what is going to be the distribution of x bar, and let see that the mean of the whether it is unbiased or not. And this whole distribution is based on x1, x2, xn, which is a random sample of size n. Okay, so x bar is this. I need to check expectation of x bar is equals to expectation of 1 by n summation xi, I running from 1 to n. So from this distribution, first of all, I need to find what is expectation of xi. I know expectation of xi is equals to alpha for all I, and variance of xi, if required, I am going to find, but I am just writing it. Expectation of xi is equals to alpha for all I. That is for sure. So if you try this out, you will be getting it. Shall I show that how am I getting this expectation of xi is equals to alpha? Is it required? Students, can you
No,
please?
ma'am.
Oh, okay. So expectation of 1 by n summation over. So I am just putting the expectation inside. So expectation of xi is going to be 1 by n summation over alpha, that is equals to 1 by n into n alpha, that is equals to alpha. So basically, x bar is an unbiased estimator of alpha. If you can see the qualities of x bar is also sufficient, x bar is not sufficient, x bar is also complete as well. So if and moreover, this distribution belongs to an exponential family, and this distribution belongs to a exponential family of distribution. This is a very important thing. This belongs to the exponential family of distribution. So basically, based on that thing, this x bar is also sufficient, complete. Rather, we can say that x bar is completely sufficient. It is sufficient and it is unbiased as well. So based on these three quality and it belongs to the exponential family, we can say that x bar is the MVUE, UMVUE of alpha. So obviously, as I told you, that this is going to be the correct option. Next, moving on to the next question. Okay, let's choose this question number 20. They're asking for that these are the data set given. The size of the data set is 12 from a geometric population, and PMF is given by this. This is the corresponding PMF. And theta, you need to find theta by the method of moments. Okay, so method of movements, so we need to write down the sample first. Okay, let us write down the sample. 12 observations. So that is the value of n. What are the observations? It is right 43636, 344 355. Okay, so these are my observation if I'm not wrong. So just check it once before you write it from the question. So these are my 12 observations, and my PMF fx is equals to, it's already given in form of theta, if you can see. It's theta into 1 minus theta to the power x minus 1, where x runs from 1 to up to infinity. Okay, this is the form of the distribution. So we need to find the estimator of theta by using method of moments. So do you know what is method of moments? Okay, x bar is 1 by n summation xi. This is the formula of x bar. So now we need to find expectation of x of this particular distribution. Okay, let me show it. For this distribution, I am finding out the mean. Okay, can you tell me what is this series? What will be the value of this particular series? Anyone? Anyone who knows the value of this particular series? Okay, I am showing it over here. If you can recall, 1 minus x, 1 plus x whole to the power minus 1. This was a formula which you have learnt in your plus 2 level. This gives you 1 plus x square plus x cube plus dot dot dot, something like this. Okay, now I am doing the derivative of this formula from both sides. Okay, derivative from both sides. What it's going to give me? Minus 1. Sorry, I have written this wrong. This is going to be minus 1 minus x. Minus 1, 1 minus x to the power minus 2. Again, there will be a minus 1. That is going to be equals to 0 plus 1 plus twice x plus 3x square plus dot dot dot, and ultimately the finalized things will be 1 minus x to the power minus 2, that is equals to 1 plus 2x plus 3x square plus dot dot dot. If you can see the right side, it exactly matches with this 1 plus 2. This is, if I consider it to be some x or something, 3 into something like x square, same as this thing. Okay, so I can write theta into 1 minus theta to the power minus 2. So that is going to be theta into 1 minus 1 plus theta to the power minus 2. That is 1 gets cancelled out. Theta into theta to the power minus 2. That is theta to the power 1 minus 2. That is 1 by theta. That is going to be the mean of this particular distribution. So now my first order moment expectation of x I got as 1 by theta, which should be equals to my x bar, which is 1 by n summation xi. Okay, from this thing I need to equate it and need to get the value of theta. So where am I supposed to get this value of summation xi? From this actually values which I have written over here. These are my xi values, and value of n is this 12. Okay, so I need to add them up. So let's open a calculator and add them up. Please add them up and tell me what you are getting. It's very easy to add. I think the total is 48. Am I right?
Yes, ma'am.
Okay, 48 by 12 is equals to 1 by theta. So that implies theta is equals to theta hat. The estimate will be 12 by 48, which would be approximately 0.25. And let's check whether it's the, yes, is 0.25. Is it clear?
Yes, ma'am.
Okay, let's start question number 23, the MLE of uniform distribution. Okay, they are asking that whether, do you know consistency? Okay, then let's start this question 24. Okay, there is a sample, random sample of size n given from Poisson distribution with theta. They are giving two statement that 1 by n summation xi is MLE or not, and 1 by n summation xi. Okay, so you need to check for that. So first of all, do you know the answer, or shall I chalk out the whole question? Okay, I am showing it again. So let's start. So it's given that x1, x2, xn, it's a random sample of size n. Okay, given from what distribution? From Poisson theta distribution. Okay, so I need to find out that the question says that this 1 by n summation xi, rather I should say x bar, is the MLE and is the sufficient estimator of theta or not. So let's first start with the sufficient estimator. What is the definition of sufficient estimator? First we need to find out the joint distribution. The joint distribution says e to the power minus n lambda, sorry, n theta, theta to the power summation xi running from 1 to n into product over xi factorial I running from 1 to n. This is my joint distribution where xi takes the value starting from 0 to up to infinity for all I running from 1 to up to n. Okay, this is my joint distribution. So can I express this in form of this thing, g of t of some x curl and theta and some h of x curl? Okay, so is it possible to write? Yes, it's possible to write. If I split this function up, then where I can write my h of x curl, which is going to be a function only of x curl. Here the function is 1 by product over xi factorial. I runs from 1 to n, and my g of t of x curl comma theta, the joint function of the parameter and a joint function of the statistic. This is the statistic. Is basically e to the power minus n theta into theta to the power summation xi. So basically that gives me my t of x curl is equals to summation xi. So I can write like I can modify it a little bit and I can actually write my t of x curl is equals to 1 by n summation xi, which is equals to x bar. So that is sufficient for theta. So the statement which is given over here, whether it is sufficient or not, so statement 2 is true. So both neither 1 and 2 we can discard this option. 2 only we can keep this, 1 only we can discard this option. Both 1 and 2 is also true, but whether 1 is true or not, that is like we need to verify. For 1, that is to find the MLE, we again need the joint distribution. Rather, we will be needing the log likelihood of the distribution. Here, the joint distribution f of x curl, I am writing it again, is called likelihood function. Now I am going to take the natural log of this particular function. Then it's going to give me this thing. This is actually called log likelihood. Log likelihood function. Then we need to do the partial derivative of this log likelihood function with respect to the parameter theta. Is the distribution or the joint distribution contains more than one parameter, suppose theta 1, theta 2, or maybe at least two parameters. So that's why we need to do the derivative, partial derivative with respect to the one parameter, keeping the other as constant. Suppose the distribution contains two parameters, theta 1 and theta 2. So we need to do the derivative with respect to theta 1, keeping theta 2 constant, and then we need to do the derivative of theta 2 with respect to keeping theta 1 constant. So this is only possible if we go for the partial derivative. So that's why we are doing the partial derivative with respect to theta, and that is going to give me minus n plus summation xi by theta minus 0. Since this is a fully function of xi, so no theta is involved over here. Then we need to equate this log likelihood first derivative, partial derivative with 0. It's same as like Emily method is same as finding the maxima minima which you have learned in your class 12, only if the method will be same, only if you don't see like if the range of the distribution does not contain the parameter. If the range of the distribution contains the parameter, then only there will be a problem. Otherwise there is no problem. You can actually continue in the same method. Okay, so if we are equating this, then we are getting summation xi by theta is equals to n. That is actually giving me theta is equals to summation xi by n, that is equals to x bar. Now, this is the value of theta which we have obtained. We need to do a checking that whether this value is giving me the maximum of the likelihood or not, because we are finding or we need to find the value of theta for which our likelihood is going to be maximized. That's why we need to do a second order partial derivative of this likelihood function, which is going to give us basically minus n for 0, and then there was a like this was the function, then we are going to have plus summation xi, and for 1 by theta we are going to have minus 1 by theta square. This is going to be there. So ultimately we are having minus summation xi by theta square. Next we are going to put the value of next we are going to write the value of we are going to put the value at theta equals to theta, sorry, theta equals to x bar, that is equals to minus of summation xi by x bar square. Whatever be the value, at least this minus signs confirms this is going to be negative. That means if I am going to take this value theta equals to x bar, my equation or my likelihood function is going to give me the maximum value. Hence, theta hat MLE is equals to x bar. So, as per the question, not only two, both 1 and 2 are satisfied. Is it clear? This is the same procedure which you need to follow for PMF and PDF, rather than the conditions where the parameter is involved in the range of the distribution. If the parameter is involved in the range of the distribution, you cannot proceed with this particular method. Otherwise, you can proceed with this particular method and you will be able to find the MLE. Is it okay? Next, going for question number 26. X1, X2, Xn is a random sample from a population with PDF. This is the PDF given, again exponential distribution. We need to find the Kramer-Rao lower bound, CRLB. They are asking for the CRLB to the variance of an unbiased estimator theta. So we know the formula of CRLB, that CRLB is equals to some psi prime theta by I theta. What is now here? What is my psi theta? Here psi theta is theta itself. And what is my I theta? I prefer using the formula of I theta as expectation of del square del theta square of the log minus of the log likelihood. I prefer this formula. Even you can take the single derivative formula as well. I prefer using this one. Okay. So let's start. Let's see the once again the see once again the PDF. 1 by theta e to the power minus x by theta. Okay. Just a minute. Let me scroll down a little bit. So again x1, x2, xn is a random sample from fx equals to 1 by theta e to the power minus x by theta, where x greater than 0 and theta greater than 0. Okay. So we need to find the CRLB. So the first process of finding CRLB is again to find out the joint PDF. So f of x curl is 1 by theta to the power n e to the power minus 1 by theta summation xi, where xi is greater than 0 for all I running from 1 to up to n, and theta is greater than 0. So this is my joint PDF, which is called likelihood. Then the log likelihood, which is going to be log of 1 by theta to the power n minus 1 by theta summation xi. Now obviously this portion of is going to give me minus of n log theta minus 1 by theta summation of xi. The simplification. Then we need to do the derivative of this with respect to theta. It is going to give me this thing. Here we already need the second derivative before proceeding with the expectation. This is theta to the power minus 2. So basically we are going to get minus 2 into minus 1 by theta cube. So that is giving us n by theta square plus 2 by theta cube summation xi. Could you please check the calculation once? Is it okay?
Yes, ma'am.
Okay, now I'm going to put expectation with a minus sign of this.
Excuse me, ma'am.
Yes.
Ma'am, in the second derivative,
Yes.
I think there's an error.
Yes, where is it?
I think it should be n by theta square minus 2 by theta cube sigma xi.
That's why I ask you to check once. Thank you so much. Because whenever I am doing this derivative, just showing it in a graph, whenever I'm doing this derivative, it's going to be minus 2 into theta to the power minus 2 minus 1, right? As per the formula of the derivative. So it's going to be minus 2 theta to the power minus 3. So minus 2 by theta cube. So where I'm going to get this minus? That's why I deliberately ask you to check the calculation once. Thank you so much. Very good. I'm just rubbing this portion, okay? Otherwise, you will get confused. Okay, now as I am putting a minus sign before this, so everything is going to be changed. I'm just writing in a reverse order. Xi minus n by theta square. And the expectation is outside this. So it's going to be 2 by theta cube summation over expectation of xi I running from 1 to n minus n by theta square. So basically 2 by theta cube. What is going to be my expectation of xi? My function was 1 by alpha and it was 1 by theta or 1 by alpha. I forgot. It was 1 by theta, yes. It was 1 by theta into e to the power. It was 1 by theta into e to the power minus x by theta. So obviously expectation of xi is going to be theta. So basically it's theta into n minus n by theta square. So what I am going to get 2n by theta square minus n by theta square, that is n by theta square. Is it okay? So basically my I theta is n by theta square. My psi theta is theta, which implies psi prime theta is equals to 1. So my CRLB is equals to 1 by n by theta square, that is theta square by n. Let's see. Yes, this is my option, theta square by n. Is it okay? Any confusion, any doubts?
No, ma'am.
Okay, let's proceed. Okay, let's start with question number 31. Okay, so they are asking that a single random variable having a standard normal distribution 0, 1. So we need to find expectation of mod x. Okay, so there are four options. So what people usually, okay, let me write the question first. Okay, so x is a random variable which follows standard normal distribution 0 and 1. And we need to find expectation of mod x. Okay, now what people usually get confused that since this is normal, so we are dealing with PDF. So we are dealing with PDF means we need to do the integration and itself whether if it is a standard normal PDF also the function is very complicated. So people start doing this thing that expectation of mod x is where they start doing this that integration of minus infinity to infinity this mod x into fx dx where this fx is the PDF of normal 0, 1. So this is a very wrong procedure. Not, I won't say this is a wrong procedure, but this is very big procedure. This is not at all applicable for this particular objective question. What you can do over here, you can apply a very small trick. What small trick? We know a result that mean deviation about mean. Suppose, okay, let me start with the first. If x is a random variable, so let me write with another color. If x is a random variable following normal mu sigma square, then the mean deviation about mean is expectation of mod of x minus mu. This is the formula of mean deviation about mean, and which is basically root over of 2 by pi into sigma. This is the result we know. This is the result we know. We already know this thing. This is the result we know because this is a well known property of normal distribution. Right? So now for my case, what are the changes is over here? For my case, this mu is 0, this sigma is 1. So if I am using this result directly, what I am going to get? Expectation of mod of x minus 0 within the bracket is equals to root over of 2 by pi into 1. Basically it's 1 square, so I'm going to get 1. So that is basically expectation of mod x is equals to root over of 2 by pi, which they are asking for, right? Now read the question very carefully and see what I am telling actually. So this is going to be your answer. Shall I repeat that thing or is it okay?
Ma'am, it's clear.
Okay. So let's move on to another sum. Okay, this is a very small sum which I am just discussing. Question number 38. It's stating about the properties of Emily. Okay, first of all, is Emily unique? So what do you think? Is Emily unique? Like I have just found out the MLE of a Poisson distribution with parameter theta, and the MLE came out to be like x bar or summation xi x bar, similar kind of thing. But the thing is that MLE is actually not unique. Okay, MLEs are not unique. Okay, first let me tell you the answer. The answer is 2 and 3 only. Okay, for question number 38, the answer is 2 and 3 only. That is, these two options are correct. MLEs are unbiased, MLEs are consistent, but they are not unique. Okay, MLEs are always consistent. That is going to be true because this is like, since we are doing the derivative and taking the log likelihood, so it's a large sample property can be you can apply this large sample property and it will hold basically. It is like unbiased, fine, but MLE is not at all unique. Like I told you that this class 12 concept of finding maxima minima is applicable, or you can apply for finding MLE only if the range of this particular distribution or the function or PMF or PDF, whatever is given to you, does not contain the parameter in as the range of the x. Okay, so in that case only this method is applicable. Otherwise, this method is not applicable. Then you have to find out a way or any value of that particular x. Obviously, you need to find a statistic. Whenever we are discussing about estimator, it's basically nothing but a statistic, which is nothing but a function of solely a sample observation. So obviously, you need to find a statistic which is going to maximize your function, your PMF or your PDF, or rather to say your joint distribution function. So, which is going to maximize your joint distribution function? That function may not be unique, and even you can have more than one function, and that as a whole, you can choose the convex combination of these two functions as well to find the MLE of that particular distribution. So you cannot claim that MLE of a distribution is always unique. So for this particular sum, we only one is false and 2 and 3 are correct statement. Is it okay? Next, let's go for a very small sum. Okay, now go with the first sum. Okay, question number two. Can you answer question number two, which we have discussed in today's class? A similar kind of sum. Instead of just ANOVA 2A, ANOVA one-way model is given. If you can see here also, tau 1 and tau 2 is given together, which is not possible to estimate. So 2 is not estimable. So both 1 and 2 we can discard this option, neither 1 and 2 we can discard this option, and only 2 we can discard this option. Okay, so only option left is 1 is estimable, and obviously mu plus tau 1 is estimable because mu we can estimate separately, tau 1 we can estimate separately, but and also the joint estimate which is possible, because at a time if we can fix I, fix j, and we can estimate the both the things together. But this tau 1 and tau 2 cannot occur together, because both the treatment, if we consider this to be a CRD design, both the treatment cannot occur together. So hence tau 1 and tau 2 cannot be estimable, but mu plus tau 1 is estimable. Okay, that's why this first one is only estimable, but 2 is not estimable. Based on the similar logic which by the sum which we have started the class with. Is it okay? Clear? Any queries from anyone? Any queries, anyone?